Hello students, today we'll be discussing ecosystem concepts for urban integration. This is a new module. The fifth week, the module is on this integration of ecosystem theories and concepts. So there we'll be discussing 5 different topics in this week. So first one for today's discussion is ecosystem concepts for urban integration. What we will cover under this key concepts which we had discussed earlier: urban integration application, instruments, metrics for assessment, analytical tools, and definitely case examples. For this particular lecture, we have to have a very strong recap of lecture 8. So I will suggest all of you revisit lecture 8 on ecosystem concepts, where we have discussed ecological niche, keystone species, population oscillation, nutrient upwelling, environmental optimum, top-down control, biogeochemical cycle, and self-regulation. And if you remember, we had also discussed several examples, but all from natural ecosystem side. So today we have to also remember the lecture 18 and 19, where we have discussed 6 dimensions of ecosystem balance, imbalance and balance. So biophysical, ecological, chemical, socio-ecological, economic, institutional, and temporal. To move from ecological stress toward resilient urban functioning, each of these 6 dimensions we discussed must shift from threshold exceeding conditions towards states where each dimensional processes operate within safe and regenerative limits. So that is the ecosystem balance. So this ecosystem balances the dimensions as well as those concepts which we discussed earlier. They will help us to understand today's topic, that is urban ecosystem concepts. You can see those 6 dimensions and the urban ecosystem is in the focus. So we will go dimension wise. The first dimension, if we remember, is a biophysical dimension. Natural analog concepts which we have discussed, that is environmental optimum, which talks about comfort envelope for life, and the biogeochemical cycles which ensure resources are recycled, not depleted. If we try to translate these concepts in the urban context, we have to understand that they represent the physical setting: land, water, air, and built form. It determines resource availability and constraints like temperature moderation, hydrological balance. Urban environmental optimum would be conditions under which built and natural components coexist most efficiently. So thermal comfort zones, sustainable groundwater levels, they are necessary conditions. So some of the applications of this concept, let us see: sponge-city drainage corridors, permeable paving and infiltration basins, urban ventilation channels, street geometry, canopy volume optimization along heat corridors, groundwater recharge zones in zoning maps. What are the instruments we can use here? Impervious surface ratio, ISR caps, urban cooling overlays, setback rules for riparian buffers. Only having these instruments doesn't really mean everything. We have to have the instruments, we have to implement them also. Other 2 instruments which I would like to refer here are the soil volume standards per tree, which shall be more than 30 cubic meter per tree, and rainwater harvesting mandates. How to assess the metrics for them: MRT, watt per square meter, deep infiltration, cubic meter per hectare per year, evapotranspiration deficit in percentage, surface runoff coefficient changes, land surface temperature in degree Celsius differences. Analytical tools: ENVIMAT, urban microclimate simulation tools. I think many of you are also using it not only you know about them. SWIM, stormwater runoff modeling, WRF, urban canopy meteorology, iTree hydro, water interception. There are n number of tools. I have just brought few of them. So let us go for a good example under this biophysical dimension. Copenhagen Cloudburst Management Plan of Denmark, which was developed in response to the 2011 extreme cloudburst, which caused them more than 1 billion euro damage. Adopted in 2012 as a 20-year citywide strategy to manage increasing intense rainfall events. So the goal of this particular plan was reduce flood risk and increase climate resilience in Copenhagen. And it combines traditional drainage upgrades with innovative blue-green surface solutions. So both the engineering as well as nature-based solution. Covers some 300 projects prioritized by flood risk, feasibility, urban development, and synergy opportunities. Public-private partnership among the City of Copenhagen, Greater Copenhagen Utility, and private landowners were compulsorily required to make it successful. Total investment of about Danish kroner 3.8 billion, approximately 510 million euros over 20 years. So it's a huge amount of investment, but with the commitment from both the governance as well as the people. Infrastructure includes 7 to 8 kilometers of underground cloudburst tunnels designed for extreme rain events as shelter. Over 100 kilometers of stormwater roads and surface runoff routes built or planned to handle overflow. Blue-green solutions like green roofs, bioswale parks, and detention basins offer 20 to 30% of rainwater retention capacity. Risk-based annual project selection focuses on areas with highest flood risk to optimize the impact. This is very important decision. Multifunctionality of this plan is like tunnels, stormwater roads. They also will serve urban traffic and recreation when the situation is dry. For this particular project, all the referred SWAY model and this ENVIMATE, all these analytical tools were in use. And the estimation is that this particular project will save millions annually after it gets implemented. Next dimension for discussion will be the ecological dimension. First, let us have the concepts. What are the natural analog which is going to be relevant for urban integration under this ecological dimension? Ecological niche, keystone species, population oscillation. I hope you remember all of them. Let us see the urban translation. These dimensions define roles of green and blue infrastructure like urban forest, wetlands, water bodies like ponds. Ecological niches correspond to spaces supporting diverse life forms even in built context like rooftop garden, urban wetlands. Keystone species could include pollinators, urban trees, or even community maintained gardens that sustain local biodiversity. Population oscillation will get translated into fluctuating urban species and their presence or vegetation cycle. Urban integration applications, we can see ecological corridors via street tree canopies, pollinator rooftops, stepping stones, riparian buffer restoration, multi-strata urban forest, understory, mid-story and canopy. What are the instruments we should refer here? We can refer easily the Berlin Biotope Factor. Malmo has also used it. It's a wonderful instrument where every plots are having the responsibility to be ecologically responsive. Urban biodiversity action plans, habitat banking offsets, corridor easements with development control regulations. So, all are effective instruments in many different global conditions. Now, let us discuss the metrics for assessment. Effective mesh size, delta probability of connectivity, patch cohesion index, bird and pollinator richness counts, canopy connectivity in percentage. Each one of them are so interesting that it will take a lot of time to discuss. So, I will advise, if you are interested, please look at them individually. What are the analytical tools which are in use to understand this ecological dimension? Circuitscape, connectivity modeling, cone for Sensinode, graph-based habitat analysis, Markson conservation planning, NDVI, NDWI time series for remote sensing image. The case example which we will be discussing here, that is Singapore Skyrise Greenery Program. Singapore is one of the most model example that how today's urbanization is going forward as far as urban morphology is considered. But even in these sky rises, you can actually include the ecological dimensions. So, in this particular greening program, we could see that which was launched in 2009 and it was led by National Parks Board of Singapore. This particular program aimed to integrate greenery vertically through green roofs and green walls to enhance urban biodiversity, provide ecosystem services and mitigate urban heat island effects. Since inception, the program has created approximately 155 hectares of skyrise greenery as of 2023, nearing the target of 200 hectares by 2030, equivalent to about 155 football fields of vertical and rooftop greenery. So now you can see we cannot make any excuses. We can easily integrate green even if we are going vertical. This incentive scheme that was funded over Singaporean dollar of 10 million plus, they supported the green roofs and walls on more than 100 buildings, including residential, commercial, schools and museums. Building Biodiversity Service documented 265 plant species and cultivars across 1.86 hectares of skyrise greeneries, with species richness averaging 124 species per hectare. What a strong amount and healthy number we can see here, promoting urban ecological connectivity. Localized microclimate cooling effects, which comes as a multifunctional one, that result in MRT drop in 1 to 3 degrees Celsius, and definitely it will help to mitigate not only the UHI but also the cooling load. Skyrise greenery reduces building rooftop heat gain, lowering cooling energy demand and improving the energy efficiency. Integration of green roofs with solar photovoltaic panels that increase the energy yields also and supported shade tolerant vegetation, enhancing ecological resilience. So, it's a wonderful example for today's urban areas. Next important dimension which we will be discussing, that's the chemical dimension. Because if we remember that in the cities, these chemical flows are actually being intercepted like anything. So, which are the natural analog concepts relevant for this discussion? Nutrient upwelling and biogeochemical cycle. Urban translation, let us see, that will include the circulation of pollutants, nutrients and emissions through urban air, water and soil systems. Urban analog of nutrient upwelling might be resource cycling, composting, waste to energy and grey water reuse. It will focus on maintaining chemical balance to prevent air and water toxicity. Applications we can find through constructed wetlands for nitrogen and phosphorus removal, green walls for volatile organic compounds absorption, vegetation particulate entrapment, leaf morphology selection, bioretention soils for heavy metals, photocatalytic pavements for NO2 breakdown. The instruments which are being in use are the local airshed zoning regulations, water quality trading schemes, industrial effluent load permits, stormwater pollutant load targets, and VOC urban material guidelines. The metrics for assessment for this particular dimension, we can take note of PM 2.5 deposition flux, total nitrogen phosphorus removal in percentage, VOC concentration, soil heavy metal concentration, AQI component score reductions. That again there will be lot of different analytical tools available to help us, like air pollution dispersion model, CMAC chemical transport modeling, SWIM water quality, ICP OES for soil chemical analysis. So, like that there are several different analytical tools available. The case example which will be discussed here, that is Cheonggyecheon restoration of Seoul. I hope you remember this particular case, Cheonggyecheon. We had discussed it earlier. So, in continuation to that discussion, now we will be discussing the chemical dimension. Fine particulate matters PM10 concentration was dropped by approximately 35%. So, from 74 to 48 micrograms per cubic meter. What a significant number. So, definitely significantly it improved the air quality and reduced respiratory diseases among the residents. Nitrogen dioxide levels, that was also reduced by around 34% post restoration, contributing to better atmospheric conditions. The volatile organic compounds and other air pollutants, they also showed rapid changes. They decreased shortly after the project completion. Local temperature decreased by about 0.9 to 3.6 degrees Celsius in the restored stream corridor. That's a good achievement, mitigating the urban heat island effect. In continuation, we can keep on discussing other benefits like wind speed in the area that got increased by 2.2% to 7.8%, and it enhanced the ventilation and pollutant dispersion. So, in an humid condition, you can easily understand that it is a great relief. Flooding was effectively controlled through strategic basin design, accommodating a 200-year recurrence interval flood, eliminating previous inundation issues. Biodiversity sharply increased, with plant species rising from 62 to 308 and fish species from 4 to 25, indicating strong ecological recovery. So, both the flora and fauna, they could get the advantage. Traffic volume decreased with a 2.3% drop in vehicles entering downtown Seoul, alongside increased public transit use, contributing indirectly to improved air quality. Whereas our cities are actually choking in the downtowns. So, this will be a very good example to really look at. Fourth dimension, socio-ecological dimension. The natural analog concepts are top-down control and self-regulation. Let's see the urban translation, that they capture the human behavior, governance and ecological processes co-regulate each other. Top-down control can refer to planning regulation, zoning and environmental governance mechanism. Self-regulation emerges when communities adopt sustainable practices voluntarily, like local composting, cooperative water management, green building adoption, etc. Urban integration application examples we can see like stewardships, contracts for wetlands and parks, citizen monitoring of tree survival, participatory green infrastructure mapping, co-produced rain gardens, urban agricultural stewardships. So there are n number of application potential. What are the instruments which will help? Co-management agreements like municipality and the community, participatory budgeting for green infrastructure, ecosystem service awareness programs, public trust doctrine extensions. So, these are going to be effective instruments to propagate these concepts further. What are the metrics for assessing these concepts' efficacy? Stewardship participation rate, volunteer maintenance intensity, community ecosystem service valuation survey, adoption rates of water saving behaviors, social network connectivity index. So, these are good measures for assessing this particular concept's efficacy. Similarly, we will again go for certain analytical tools references which will be helping us to work with these concepts like participatory GIS, social network analysis, behavioral dashboards, citizen science platforms like eBirds, iNaturalist. We already discussed iForest. Let us see the case example. This is a wonderful example from Barcelona, Barcelona Superblocks Initiative. So, the Superblocks initiative is an innovative urban planning model that transforms city blocks, usually a 3 by 3 grid, by restricting car traffic inside and redirecting vehicles to perimeter roads. So, it's a planning exercise, but let us see how it is helping to improve the ecological conditions of that space. This approach reclaims interior streets for pedestrians, cyclists, and community use, with measures like low speed limits, pedestrian plazas, green spaces, and recreational areas. Implementation involves tactical urbanism, modular, low cost interventions without major demolition or redevelopment. So, that way, this particular program could actually get the community's support. Average increase in life expectancy of residents are actually assessed around 200 days. Just imagine. Whereas in Delhi, we are assessing how the life expectancy is decreasing. In continuation, reduction in ambient nitrogen dioxide pollution by 24%, bringing levels within WHO recommended limits. So, good achievement. Noise pollution decreased by 5.4% from 54 decibel to 51 decibel. So, everything you can now measure. So, you have a target and you are trying to look at the changes. Estimated reduction of 230,000 private motorized trips per weekday. Very important. Replaced by public transport and active modes like walking, cycling, etc. Increased physical activity contributed to preventing an additional 36 premature deaths. Over 60% of residents, they are reporting improved walkability and comfort within superblocks, and that's a very strong number. Residents are praising initiatives, so just imagine what actually had happened on the ground. Social interactions and the community cohesion strengthened through reclaimed public spaces. So that's the way this type of initiative not only are going to be very effective for that city, they are also becoming case example for the entire world. Next dimension we will be discussing, that is economic institutional dimension. The natural analog concepts are regulatory feedbacks in ecosystem. If we try to translate it in urban context, this will ensure that institutional frameworks, incentives, and markets support ecological balance. It includes mechanisms like green taxation, sustainability linked finance, or urban commons management. That's very important, urban commons. In India, the perception is urban commons are there for destruction, not for managing. This particular dimension actually encourages resilience through economic diversity and adaptive governance. So, the application areas can be the green bonds for canopy expansion, insurance premium differentiation for flood risk, ecosystem service valuation in zoning, pollution taxes to fund ecological restorations. So, there can be many such applications which can help to bring this economic institutional dimension concept in place. The instruments we can utilize: natural capital accounting, stormwater credits, biodiversity net gain mandates, cross agency climate cells. So, there are several different instruments again present by different organizations. We will see also the metrics of assessment like value of avoided runoff infrastructure, very important. Just take a note on the term avoided runoff, heat morbidity, cost reduction, biodiversity uplift scores, governance coordination scores, green infrastructure life cycle cost ratios. So, these are the assessment metrics. Again, the analytical tool sector, we will find that several tools are available like InVest, ecosystem valuation, CBA or MCDA for decision trade-offs, natural capital protocol, risk layered budget modeling. So, these are the tools which help us to understand the target and how far we are from those targets. A good case study we have selected, that is Philadelphia Stormwater Credit Trading, or to understand economic institutional dimension of urban ecosystem. Philadelphia's Stormwater Credit Trading Program is an innovative market-based mechanism designed to incentivize property owners and developers to manage stormwater on site through green infrastructure practices, contributing credits toward regulatory stormwater volume reduction requirements. Credits are granted based on 4 performance categories: peak flow reduction up to 40%, runoff volume reduction 15%, water quality treatment 10%, and pollution prevention 5%. A sliding scale credit system allows property owners partial credits if full compliance is not feasible, enhancing program flexibility and participation. So, what does that mean? Let's say if from my plot whatever runoff is getting generated, that has got reduced, but not by 15% but by 10%. So, it will have a scaled credit. What I am supposed to get, that 100% credit I will not get, but I will get that 2/3 credit for it. So, that's the way every citizen could actually take part into this mission of stormwater run control. This program integrates with combined sewer overflow mitigation efforts, aiding water quality and flood control. It was implemented green infrastructure projects such as bioretention, permeable pavements, and green roofs. And they have demonstrated stormwater runoff volume reduction of 20 to 50% per site. Program incentives drive significant private investment in green infrastructure, easing regulatory compliance costs and promoting resilient urban watershed management. So, such an interesting program which has also taken care of the investment fully integrated into the program. As of the latest reports, The program contributes measurably to stormwater volume reduction across Philadelphia's urban watersheds, supports the state and federal water quality goals as well. That's the benefit of any positive program. The last dimension we'll be discussing, that's the temporal one, the natural analog concepts of succession, oscillation, and evolutionary adaptation addresses how urban ecosystems evolve over time, like land use changes, demographic shifts, or climate adaptation strategies. This considers resilience across temporal scales: immediate response, disaster management; medium term adjustment, infrastructure retrofits; and long term transformation like climate adaptation. So, that will be a purview of this particular dimension. Urban integration applications we can find in age structured canopy planning, multi-phase stormwater retrofits, rotational soil compaction, brownfield remediation over decades, seasonal ecosystem service planning. And some of the instruments let us discuss, that is time bound maintenance obligations, rolling green infrastructure upgrade budgets, 20 to 30 years canopy coverage targets, adaptive management cycles, dynamic monitoring ordinances. So, I think by now all of us we understood that instruments need not to be a tool, it can be a policy also. The metrics for assessment of this dimension: tree age distribution curve, soil organic carbon accumulation over time, temperature trend line decline, decadal one, pollutant load decay rates, wetland maturity index. So, these are some of the metrics for assessment. Analytical tools: remote sensing time series, scenario planning, dynamic life cycle assessments, digital twins with temporal states. They are very nice tools to help us understanding this temporal dimension of urban ecosystem. So, let us go for one good case study for this one. Shanghai Spawn City Roadmap 2030 Horizon. We have already discussed the Spawn City concept. So, first let us discuss the goal. 80% urban coverage is the goal of this particular roadmap. By 2030, Shanghai aims for 80% of its urban spaces to adopt Spawn City functions to enhance rainwater absorption and reuse, flood mitigation, and urban ecological resilience. It's a multifaceted approach, combines green infrastructure, water conservancy projects, and technological upgrades, including advanced hydrological models and risk mapping. There are sponge parks, major projects like Study Sky Park, 54 hectares, integrate ecological corridors, wetlands, permeable pavements, rainwater harvesting, and smart water platforms to regulate runoff and improve the water quality. Rainwater management standards it follows, that is the technical standards for new urban developments which emphasize source control, rainwater storage capacity, infiltration, and pollution prevention integrated into the urban planning. Ecological restoration we find in this particular case through rehabilitation and protection of wetlands and river corridors to enhance natural flood control and purification process. Let us dive deeper into this flood control design. Key spaces which include the detention basins, they are capable of handling 200-year flood events, and thus they are also mitigating stormwater surge risk in a coastal climate prone to typhoons and heavy monsoon rainfalls. So, it is looking at so many different aspects, the Spawn City. Financial investment, always we are stuck on this aspect. Let us see what this particular Spawn City program has done. This program have seen investments in excess of 13 billion USD across 16 pilot cities, with Shanghai among the leaders in comprehensive implementation. The plan mandates recycling or on-site retention of at least 70% of rainfall to reduce pollution and recharge groundwater sustainably. Use of smart water infrastructure for real-time monitoring and adaptive control of water flow and treatment is also in place, and thus it boosts urban water resilience. Several supporting policies are in place: national level PPP model, fiscal support, and innovative financial instruments underpin this particular program for upscaling and operation. With this, we have been able to discuss the ecosystem concepts for urban integration, where we discuss not only the concepts but their integration application, instruments, metrics for assessment, analytical tools, and we have also discussed relevant case studies. These are the reference. Thank you.